Hi guys, this is Utsa along with my classmate Mohit is here to present a short presentation on the topic evaluating the effects of UV light doses on the microstructure, surface color and microbiological stability of sliced apples over a 7-day refrigerated storage period, consequences for food preservation and quality control. Hope you guys will get a various knowledge about this presentation. In this experiment, me and my classmate have gone through a whole 10 weeks of process to find out the stability and freshness of sliced apples. Our research aims to address the pressing need for effective food preservation techniques that can ensure both food safety and quality. By examining the effects of UVC irradiation and pre-treatments on sliced apples, we hope to provide valuable insights for the food industry and contribute to the development of innovative preservation strategies. Join us as we explore the results of our experiments and discuss their implications for food safety, quality control, and consumer satisfaction. Moving forward, let's discuss the objective of our experiment. The objective of our study is to evaluate the impact of UVC irradiation and pre-treatments on the quality and safety of sliced apples. Specifically, we aim to assess the effectiveness of UVC irradiation in reducing microbial contamination and enzymatic browning in sliced apples. Investigate the role of pre-treatments such as blanching, calcium chloride, and ascorbic acid in preserving the color, texture, and microbiological stability of sliced apples. Determine the optimal combination of UVC irradiation and pre-treatments to maximize the shelf life and quality of sliced apples. Through our research, we seek to provide practical insights for food producers and processors to enhance food safety and quality in the fresh-cut produce industry. Now, as we move on to hypothesis, our hypothesis is that UVC irradiation in combination with suitable pretreatments will effectively reduce microbial contamination and enzymatic browning in sliced apples. We predict that UVC irradiation will demonstrate a dose-dependent reduction in microbial populations on sliced apples. Pre-treatment such as blanching, calcium chloride, and ascorbic acid will mitigate enzymatic browning and preserve the color and texture of sliced apples. The combination of UVC irradiation and pre-treatments will synergistically enhance the safety and quality of sliced apples, leading to extended shelf life and improved consumer satisfaction. Our research aims to test this hypothesis and provide valuable insights into the application of UVC technology and pre-treatments in fresh-cut produce processing. Moving forward to method and materials, for our experiment, Gala apples were carefully selected and stored at 4 to 5 degrees Celsius until use. They underwent a precautionary wash with sodium hypochlorite solution before being hand-peeled and cut into equal discs. UV irradiation was administered using lamps emitting short-wave ultraviolet light. Different doses of UVC radiation were applied varying the incubation time. We also investigated various pre-treatments including hot water blanching and chemical treatments with calcium chloride and ascorbic acid solutions to minimize enzymatic browning. Microscopic examinations were conducted to study cellular alterations induced by UVC exposure, while microbiological tests assessed the impact of UVC irradiation on microbial survival. Statistical analysis was performed using the StatGraphics Plus package to determine significant differences between experimental parameters. Overall, our methods were designed to comprehensively evaluate the effects of UVC irradiation and pre-treatments on the quality and safety of sliced apples. UVC irradiation and pre-treatment. In this section, we will delve into the UVC irradiation process and the various pretreatments applied to the sliced apples. UVC irradiation was administered using lamps emitting short-wave ultraviolet light. Different doses of UVC radiation were applied by varying the incubation time, allowing us to assess its impact on microbial reduction and browning. Additionally, we explored several pretreatments to minimize enzymatic browning. These include hot water blanching, chemical treatments with calcium chloride and ascorbic acid solution. Our aim was to investigate how these pretreatments, when combined with UVC irradiation, could enhance the quality and safety of sliced apples. Let's move on to see the results of these treatments.
Hello everyone, my name is Mohit Ahir and I'm going to talk about microscopic examination right now. Let's focus on the microscopic observation made during the study. Microscopic investigation were conducted to examine the cellular alteration induced by UVC irradiation and freshly cut apple's disc. The sample were post-fixed and embedded before being sectioned and stained for analysis. Upon examination, significant alteration were observed, particularly the rupture of cellular membrane in sample exposed to UVC. This observation suggests UVC induced cellular damage which may contribute to the higher browning or irradiated apples. This microscopic finding provide valuable insight into the morphological change occurring in apple tissue post UV treatment, enhancing our understanding of effect of UVC irradiation on cellular integrity. Now, let's discuss the microbiological studies conducted as a part of the research. The aim was to determine how UVC irradiation affect the of survival of bacteria on fresh cut apple disc, both native and inoculated. Various strains including Saccharomyces cerevisiae, Escherichia coli, and Listeria innocua were utilized in the study. Apple discs were prepared and exposed to UVC radiation for varying duration. Microbial population were then assessed by homogenizing the disc in sterile Peptone water and surface plating on specialized agar media for bacteria and yeast. Colony forming units (CFU) were counted after incubation to evaluate the effectiveness of UVC radiation in reducing microbial population. The result revealed a dose-dependent decrease in microbial population following UVC irradiation, indicating the bactericidal effect of UVC technology. However, it's important to note that UVC treatment may not completely eradicate all microbial contaminant, necessitating additional measure for comprehensive pathogen management. These microbial studies provide a valuable insight into efficacy of UVC irradiation in the controlling microbial contamination on fresh cut apple, contributing food safety and quality. Statistical analysis was conducted using the StatGraph Plus package. A two-way general analysis of variance with repeated measure was employed to identify significant difference. A significance level of p less than 0.05 was set, followed by Turkey set of interaction. This rigorous method provided a robust framework for deriving meaningful insight from experimental data, ensuring the reliability of our finding. The extensive experimental study revealed a significant finding regarding the impact of UVC irradiation and pretreatment on sliced apple, including microbiological results. Pretreatment such as blanching, calcium chloride, and ascorbic acid, along with UVC irradiation alone, had substantial effect on the color, texture, and microbiological stability of sliced apple. UVC irradiation, when paired with the appropriate pretreatment, showed promising results in minimizing enzymatic browning and preserving cellular integrity. Microscopic examination revealed less cellular damage in UVC irradiated sample compared to untreated one, indicating potential for long-term fruit quality preservation. Overall, the result underscored the importance of selecting suitable pretreatment and radiation dosage to enhance the safety and quality of sliced apple, benefiting both consumers and food industries. Thank you. Now, let's turn our attention to the observation made during our study. Firstly, our microscope observation revealed that untreated apple tissue exhibited significant browning and cellular deterioration by day 7. However, sample treated with UVC irradiation alone showed preserved cellular structure with minimal sign of deterioration or browning. indicating the long-lasting protective impact of UVC irradiation on apple tissues. Additionally, combining UVC irradiation with other treatments such as blanching, calcium chloride, and ascorbic acid showed varying degrees of preservation in cellular integrity. While some softening was observed, the overall cellular structure remained intact, highlighting the potential of this combination treatment in maintaining apple quality. Moving on to our microbiological studies, we found that UVC irradiation effectively reduced microbial population on apple sample, particularly when combined with ascorbic acid treatment. However, the effectiveness of calcium chloride treatment in preventing microbial contamination was found to be limited, suggesting the need for further research into alternative preservation techniques. In summary, our observation underscores the effectiveness of UVC irradiation and combination treatment in preserving the cellular integrity of sliced apple, while also highlighting the importance of microbial control in ensuring food safety. Thank you. Let's explore the discussion portion of our study. Firstly, our findings support the notion that UVC irradiation and pre-treatment play a crucial role in minimizing enzymatic browning and maintaining the quality of sliced apple. By carefully selecting appropriate pre-treatment and radiation dosages, food procedures can enhance food safety and prolong the shelf life of apple product. Moreover, the combination of UVC irradiation with pre-treatment such as blanching, calcium chloride, and ascorbic acid show promise in improving the overall quality and microbial stability of sliced apple. However, further research is needed to optimize this combination treatment and explore their long-term effect on apple freshness. Lastly, our study highlights the importance of understanding the complex interaction between UVC treatment, pre-treatment, and apple qualities. By gaining insights into this relationship, we can develop more effective strategies for food preservative and quality control, ultimately benefiting both consumers and the food industry. In conclusion, our comprehensive study has provided valuable insights into the efficacy of UVC irradiation and pre-treatment in preserving the quality and safety of sliced apple. We have demonstrated the UVC irradiation when combined with appropriate pre-treatment such as blanching, calcium chloride, and ascorbic acid can effectively reduce enzymatic browning and microbial contamination in sliced apple. These findings have significant implications for the food industries as they offer practical strategies to enhance food safety and extend the shelf life of apple products. By implementing this technique, producers can ensure higher quality product and great consumer satisfaction. In the future, further research should focus on refining this treatment method, optimizing radiation dosages, and exploring their applications to other fresh cut fruit and vegetables. By continuing to innovate in food preservation technology, we can meet the growing demand for the safe, high quality produce in the global market. Thank you so much.